Alright, so this is the second part of 6.1. Alright, so where we left off was example 3. This was kind of like our little to-do list. Things we want to do with this example was we wanted to write a system as an augmented matrix. This is our to-do. And we did that. So an augmented matrix is literally the coefficients, and the constant. So you can see we took this first row, right? 5, 5, negative 5, negative 5, negative 5, negative 5. You guys see where I'm circling? 35, 35. We just copied, basically ignoring all the variables. I mean, we kept, like the first column are all of our x's. The second column is all of the y's. The third column is all the z's. So it's organized. It's not just in random order, but I could take rows, switch the order around. That would be fine. So we're done with the first part, which is writing a system as an augmented matrix. Now we're performing row operations to write in row echelon form. So this is the same problem we did for the first example. Difference is I'm showing you how to do it with matrices. It's a little cleaner, a little shorter. And then the third way I'm going to show you is, in my mind, significantly shorter. So, all right. So this first step, the first step was write the augmented matrix, and then I replaced, I wanted the bottom left corner to be 0, because ideally, like, what should a row echelon form look like? What are the 3 criteria?
0's on the bottom.
If there's a row of zeros, then it's on the bottom. There doesn't have to be a row of zeros, but if there is one, it has to be on the bottom. That's 1. What's another thing we know about?
Can't you just only the first leading the term after the first 0 has to be 1?
So ideally we want this diagonal to be 1s. The 5, 2, 7. We want that diagonal to be 1s, and then we want everything underneath it to be 0. It should make like a triangle. So our triangle should be literally this portion. That's our triangle. The diagonals, all the leading coefficients are 1. And then all the bottom left-hand corners are zeros to make our triangle. Okay. So this is like what we're shooting for, just to keep our goal in mind as we go through. Sorry, Haley, do you have a question?
Yeah. Can't you just always multiply the bottom row by 0?
Well, you don't want to multiply by 0. Because in order to solve for 3 unknowns, you have to have 3 equations. In order to solve for 3 unknowns, we have to have 3 rows. Because multiplying by 0 doesn't help us solve it, unfortunately. Easier for you to look at, but then you're going to be like super frustrated because then you can't actually solve it. Yep. So the number of unknowns, you have to have the same number of equations. There you go. There's your help for science. All right, so we want to make the bottom left corner 0. So what we did was replace the third row with, let's see, the 3 times the second row added to it. So really what we were doing was we were taking this whole second row, multiplying it by 3, and then adding it to the bottom. Why did we do that? Why did we multiply the second row by 3? Why did we multiply the second row by 3?
Here is 0. Both the leading coefficients for the second and third row is 0.
Yeah, so because when I multiply this -1 by 3, it turns into a -3, and then when I add positive 3, -3, it goes to 0. Because our goal was to make the bottom left corner 0, we did that. It's literally just solving puzzles. That's what this is. Like, how do I get rid of it? Okay, well, I could multiply the third row by 3, add it, because that's a elimination method. Okay, so that was the first thing we did. Then we made the top left corner 1, because ideally we want all of our leading coefficients to be 1. In the first row, the very left corner has to be 1. So I just multiplied every single part of that row by 1/5. AKA I divided everything by 5. All right, so 1/5 of 5 is 1. 1/5 of -5 is -1. -5 times a fifth is -1. 1/5 of 35 is 7. All right, so we multiplied everything by 1/5. All right, and then, okay, so we're good with our first row. Our first row is done. Because the leading coefficient's 1, we're good to go. So then we go down to the second row. So we want to make that, the -1 right there, we want to make it 0. Because if you look on the previous page, like the directions in the previous page is like, oh, let's make A310, aka row 3, column 1, 0. Did we do that here? So we were trying to make the bottom left corner 0. Yeah, okay, so we have that done. Check. What's the next thing we have to do? Then we're supposed to eliminate 2, 1, A21. Where is that even located? Where's A21? Row 2, column 1, row 2, column 1. So that's this guy right here. Oh, okay, eliminate, aka make it 0. So that's what we're doing now. We're gonna make it 0, but like think, how could I make it 0? How can I get rid of this -1? What's something I could do? If I multiply by -1, that whole row, it turns into a +1.
Add by 1.
Add, well, see, I can't just add 1 to every single part of the row. That's not one of our, like, row equivalents. Ah, okay, exactly. Row to the top, add, multiply, add it to the top row.
Add it to the top row.
Okay. Just a little review of, like, what can we do to rows? What can we do to them? Yes, these are the only 3 things you can do that actually keep it the same without, like, changing it. You can change the order. Literally switch the first row and the second row. You're not changing anything. It's just like, oh, if I have Ian, Oren, and Jenna stand up and I switch their order, like Jenna's still gonna be Jenna. Like she did not change. Just the like, oh, now she's second in line instead of first. Like, so the row doesn't actually like change anything about it. Just like if it's on top, if it's on bottom. So that's interchanging 2 rows, multiplying 1 row by a constant, by a real non-zero number. Okay, so you can multiply the whole row by a number. You cannot add a number to every single thing. You only can multiply. Because if you have like multiples of each other, I mean, you can still like factor that number out. So you can change the order, like which ones are which row. You can multiply the whole row by something, or you can add a multiple of one row to another. These are your 3 options. Literally, when we're going through solving matrices right now, these are the only 3 options you have. So you got a 33% chance. Okay, so we're trying to make this 0. I think Gabby said, hey, check it out. I could add it to the first row. What's going to happen when I add the first row and the second row together?
There will only be 2 rows.
What happens when I add these together?
0.
Ah, so my goal is to make that 0, to make the place.
No.
Yes, I'm just reviewing because people still are confused, even though it's like literally on their paper. It's fine. Okay, we already did it, but like, you know.
Sometimes people just get confused.
I'm just trying to make sure we're all together before I go on. So the idea is you guys are following along. You're taking notes. If I don't see you actually taking notes, you're not participating. You gotta be like, don't sleep, take these notes, be an active participant, be an active student.
Be an activist.
Yeah, literally, you need to take the notes. You need to like try to connect in your brain. It's gonna be hard, but this is your full-time job right now. Okay.
So of the like specific steps, the only numbers in it that are gonna change are the when you do the reciprocal. Like it's always gonna be like 3R2 plus R3.
Right, so the rows, we're always wanting to like make the bottom left corner 0, then make the one above it 0, and then make the one beside it 0.
So like you'll have to change like the numbers that you use with like.
Yep, depending on the
so
matrix.
It's always gonna be 3 times.
Right, it depends on the matrix. Depends on the coefficients. All right, so this is what we did. We came over here and we said, okay, let's replace the second row with the second plus the first row, right? So I'm adding those 2 rows together, and then that's what I'm putting in as my second row. Because according to the previous page, adding a multiple of 1 row and another row together doesn't actually change anything. So I replaced my second row with this. You can see now 0, 1, -4, -5. And then the third step. So if we come up here.
0, 1.
Sorry, I'm trying to like show you the tips and tricks while I have that whole thing on the screen. Okay, maybe if I would highlight. Okay, start entry, blah blah blah. We got rid of the bottom left corner, made it 0. Then we eliminated the one above it. Check it. Now it's 0. Perfect. Okay, now the third thing we have to do is eliminate eliminate A32. Where the heck is A32? It's the row 3, column 2. So that's this guy. I'm gonna try to make him 0, trying to eliminate him. So, Kleenex?
Why'd you do the 5?
I saw a face. Ready?
Basketball.
Oh.
Hey, touchdown. All right.
Oh.
Sorry, Ariel. Sorry. Okay, question.
Why'd you change the 5? It doesn't say.
When I change the 5.
Yeah, true.
Wait, what do you mean the 5?
In
Sorry.
the first step.
This one?
Yeah.
Oh, because all of our coefficients have to be 1. Everything on the diagonal has to be 1. I could have waited till the end to do that, but, well, it makes it less messy. Yeah. So,
Can you multiply everything by 4? Or is that like so not okay?
which one?
That's messed up.
So the reason why I multiplied everything by a 5th is because once I have 1 as the top left corner, I'm done with that whole row. I don't have to like change it again. I'm good to go. Because right now, well, let me get rid of these like highlighting.
Well, and they all go into one.
Okay, because right now, these 2 rows are done.
Are we starting the next one? Right?
Yeah, so these 2 rows are done, right? Because I have a 1 coefficient here, I have a 1 coefficient here. Hey, I need a 1 here, but first I gotta get rid of the 4. I have to make the 0.
So you divide by, no. I
Well,
don't
let's see.
know.
How can I get rid of this 4? How can I get rid of this guy?
Oh, I have an idea. Multiply the top row, like the one above it, by 2,
Yeah.
and then subtract them.
What are you saying?
Right?
One more time?
Never mind.
No, one more time. Like I didn't.
No, I
No,
don't
say it. You were. Just try it. Try it.
No, I don't want to
Negative
anymore.
4.
He said to multiply the top row by the.
Not the top row, the middle
The middle
row.
row by 2.
So you could make it 4 and then subtract like the middle's 4.
Yeah, multiply the middle by 4. But if I'm
Negative 4.
by negative 4. Is that what you said?
Yeah.
Yeah, that's what you're supposed to do. Check it.
Oh, okay, I meant 4. Sorry.
Let's see.
Guys.
Oh, we have a pause. All right, Oren's here. Osher's here. Nathan's gone. Maya. See you, Addie.
Where's
Jonah. Emma. Gabe is here. Shani. Sarah.
She's an appointment.
Okay. Gabby. Haley. Hannah. Okay, whatever. Yeah. Okay. Thanks. Try not to forget to see my attendance. It's my downfall. All right. So now we want to make this 4 a 0. So Ian was correct. What we want to do. What we want to do is replace E3 with negative 4 times E2 plus E3.
Isn't it E2?
So I'm multiplying the second. Oh shoot, it's R. I should put R's because it's row. Yeah. So I'm gonna like show you what this means. Sorry, we were working with equations last time. Okay, so multiply the middle row by negative 4. So I have 0, negative 4, 16, 20, 0, 4, negative 2, negative 6. And when I add them, all right, so I'm going to rewrite my matrice.
Wouldn't it be 6?
16 plus negative 2 is 14.
Oh.
Cool.
Does the row above stay like the negative row?
Yep, the row above doesn't change at all. Because I just replaced row 3. I didn't change anything in R2. I added a multiple of R2 to the third row, I didn't change the second row. Okay, so we're close. We're getting there, right? The last thing we need to do to make sure this is in triangular row echelon form, like, what's the last step? All right, so exactly. We need to fix this 14. I need to make it 1. I need to make this a 1.
I mean, these angles.
Multiply the reciprocal.
I have a question.
Because the whole, just a second, the whole diagonal has to be 1s. And right now I see a 14. No bueno. So what I'm going to do, am I good to scroll a little bit over? I think I'll just do that. Okay. So what I'm going to do is replace R3 with 1 over 14 times R3. Unlike dividing by 14, but another way to say divide by 14 is multiply by 1/14. 1 over 14. Okay. Think I don't need to show you the intermediate step for that one. Hoping. Okay. 1, -1, -1, 7. 1, 1, -4, 1, -5, 0, 0, 0. Okay. Oops. Okay, so is this in row echelon form?
Yeah.
Hey, check it out, right? Because I got this nice little triangle action going on. That's not pretty nice. Little triangle. It's run row echelon form. Okay, so how would I solve it? Do we know?
I don't remember.
Okay.
We start with Z.
Yeah, you start with this one. Because remember, the first column are my x's, the second are my y's, the third is my z. So to solve it, I start with z equals 1. Okay, cool. So I'm done with that row. Then I work my way up to row 2. So I have y minus 4 times z equals -5. This feels very familiar. And then I work my way up to the first row. Sorry, what'd you say? Do I need to zoom out a little, or are we okay?
Can you like write the equation first? Z equals 1.
Like what the equations are, without plugging them in?
Yeah.
Okay, so x minus y minus z equals 7, y minus 4z equals -5, z equals 1. So this is like what I'm plugging into. This is from the matrix, our triangle matrix.
Yeah.
The first column, x. Second column, y. Third column, z. All right. Cool. All right, so while you guys finish writing down, I'm going to talk about the next thing, which is the Gauss-Jordan elimination. The Gauss-Jordan elimination. If we continue the process of applying row operations to the row echelon form of the matrix, we can also eliminate the entries in the upper right-hand corner. So this is called reduced row echelon form. So reduced row echelon form, literally, you have 1s on your diagonal. Everything else is 0 except the numbers on the very right side.
So before we were putting it into Gauss.
We were putting it into the Gaussian elimination method. We're putting it in row echelon form, the triangle.
Yeah.
If we would just keep going through and eliminate everything in the top right-hand corner, aka if I wanted to eliminate these 3 in the top right-hand corner, that would be the reduced row echelon form, where the first non-zero element of each row is 1, and the rest of the elements in this column are 0. So this is the Gauss-Jordan elimination. So like the Gaussian elimination puts in a triangle. Like I guess Jordan went through and was like, nah, let's go further. Let's go further. Let's have the whole top right be 0. All right. Sorry, what? In the blue? It was the 1s, because the 1s are the like coefficients. The first non-zero of every element is 1. And then the rest are 0. So the rest are 0. All right.
Oh.
All right, so this one, what's wrong?
Yeah.
This won't be, I don't think this one's too bad. All right, so here's my system. Oh, it's actually example 4. All right, so Jenna, do you want to read the example 4, blah, blah, blah. You want to read out loud for me? Let's see.
X.
No, like the directions. What's the direction say?
What do you mean?
Directions on the page.
Solve the system of,
Okay. Solve the systems of equations by using Gauss-Jordan elimination. Gauss.
okay, so what's the first thing we should do?
Augmented matrix.
We're going to write our system in an augmented matrix. So I want you to try it out, because we learned how to do this last time. And then we're going to do reduce row echelon form. All right, so row 1, row 2, row 3. So how do you know, like, how to write your augmented matrix? What do you do when you figure it out? How do you do it? We don't know. Okay. Yes.
You take the coefficients of each variable in each row.
Exactly. We take the coefficients. So I have 1, -1, 1, 3 as my first row. -1, 2, -1, 2. 2, -3, 3, 8. But the important part is they have to be in order. Like literally my x's all have to be in the same column. My y's all have to be in the same column. Z's all have to be in the same column. Alright, the variables go by column. Okay.
Oh.
Okay, so I wrote the augmented matrix. Check that off. Now I need the reduced row echelon form. So what's the first step I should do? Do you remember how to do it?
That's what we're trying to get.
I'm trying to get it.
You start
Add the first
each
two
Make
rows.
the negative one to
non-zero
0
one.
Add
on the second row.
So what's the first step we like want to do?
Wait,
So
I
the
don't get what
tips
we're trying to do.
tips and tricks.
Oh wait, the left.
I wanna-
the left bottom corner.
Bottom left corner. Okay. So Jen said she doesn't know what we're doing. So we want to do it. We want to put it in reduced row echelon form, aka I want my matrix to look like this. I want it just to be where the blue is. That's the only part I want there to be numbers. I want zeros. Everything else. Yep. Which means we just won't have the bottom row. That's it. Because the bottom row was zeros. It's fine. So we want it to look like that.
Wait. What is it?
It's on the previous page. Okay. So we want it with only ones in the diagonal. All right, so the first thing I want to do is fix this bottom left corner. Get rid of it. I want to get rid of it. I want to make this 0.
You always start with the bottom left.
Yep. Start at the bottom left. All right. Wait, let's pause for a second. Am I good with R1? Do I need to change my row at all?
No,
No, why? Why is it okay?
because it's supposed to start with 1.
It's starting with a 1. Yeah, look at this. High five yourself. You are done with row 1. You're a third way there. All right.
The second two numbers are supposed to be 0.
Yeah, it is.
So you're not done.
We're not done, but we're going to start at the bottom left corner. We had to make it into a triangle first, and then we'll go through and get rid of everything else.
Triangle.
Okay, so we're going to make the bottom left corner 0. So we're going to replace the third row with, let's see, how do I get rid of the 2 in the bottom left corner?
Multiply the other one by 2.
Multiply R2.
R2.
Exactly. 2 times R2 and add it to R3. So -2 for -2 for adding it to 2, -3, 3, 8. So normally this stuff like in gray with this, I don't normally show it, but Yo, check it out, it's on your notes. Okay. So this is 0, 1, 1, 12. All right.
Nice.
Move it over a little bit. Rewrite our matrix. So 1, -1, 1, 3. Oops. So I only changed the third row. A lot of the writing on here is literally like, okay, copy over what our matrix looks like now. It's just being very clear so we don't like screw up. Making sure I know what my rows are as I change them. Okay, bottom left row, bottom left number done. Now I want to come up and make this one 0, right? Make the one above it, the row 2, column 1, make that 0. Do we know?
Wait, do we need to go in specific order?
Yeah, bottom left corner, middle left, middle
Do
bottom.
Negative R3. Oh, no, wait. Yeah.
We just add the first 2 rows.
Replace row 2 with R1 plus R2. So the order, the order we go through, it's like 2 pages ago. It says tips and tricks at the bottom of the page. 1, start with the entry in the bottom left corner. 2, eliminate the one above it. 3, eliminate the one that was to the right of it. So you go to the bottom left corner, then you go to the one that was above the bottom left corner, then you go to the one that was to the right of the bottom left corner. Okay. So replacing R2 with R1 plus R2. So just show you the math. Let's see. 1, -1, 1, 3. Add these together. You get 0, -1. Ooh, 0 and 5. Is this what you got?
Yeah.
Hey, okay. 2 for the 1. 2 for 1 special. It's 1. Perfect. Even better. 2 for 1 special. All right.
Okay, so
Okay. So now I have 1, -1, 1, 3. Let's see. 0, 1, 0, 5. And then 0, 1, 1, 2, 12. Okay. So, So, okay. In good news, we have 1s on our diagonal. Okay, so that's good. But what's the next step? Like we do bottom left corner, the one above it, then we go the one next to it. Okay, so the one I'm looking at is here. This is the one I need to make 0. Okay, so how could I make that one 0?
Are we allowed to? Wait, we're allowed to search orders and add them together, right? So make the top one and the bottom one adding to each other, right?
Yep.
R1 plus R3.
Let's see if I add them.
And you get 0.
No, but then it's gonna.
Oh, but then it's gonna be 2.
No, just
Tricky.
multiply the middle one by -1 and then add them.
Exactly. That's what I do. So that was brilliant. Okay, that was good. Let's see. All right, so we're on the right track. So we're going to replace the third rows. I'm trying to like color code so the matrix is all in the same color, but each step I do is different. I don't know if that's crazy. Okay, so replace the third row with. So I'm going to do like R3 plus -1 times R2. When I multiply R2 by -1, then add it to R3, it's like I'm subtracting it. Yeah. I can multiply by -1 and then subtract. Hey.
Yay!
Okay, whatever.
R3 minus R2.
Yeah, that's what I'm trying to get at. Whoop. That's the same thing. Because we can add 2 rows together, That's something that's on our list we can do. I can multiply a whole row by a single non-zero number. So if I multiply, the whole row by -1, then I add it to R3, well, it's like I'm subtracting it. So that's what I'm going to do. I'm going to take R3 and subtract R2. Don't forget to distribute your negative. There we go. 0, 0, 1, 7. Okay, cool. All right. So we're super close. We're super close to being done with this. All right, so check it out. I have ones on my diagonal. Right? I have the ones on my diagonal. I have the zeros here and here. The last thing I need to do is
top row.
Yeah, I gotta fix those zeros in the top row. Okay, so the one I'm going to, let's do this. So the first one I'm going to do is I'm going to make this one 0. How could I make this 0? What would be,
Why do we need to make that 0?
So in reduced row echelon form, there's zeros, yeah, that's supposed to look like.
Oh, it's different than the other.
It's not just row echelon form, it's reduced, meaning everything's 0 except the diagonal.
And then you have to add.
So what if I just, exactly, replace R1 with R1 plus R2. All right. 1, 0, 1, 8, 0, 1, 0, 5.
Do you guys have a final?
Yep.
Is this still gonna be on it?
Nah, I think I'll teach you this for 3 weeks and not put on your final. So, yeah. Yeah, you will. Sorry, that was mean. I should be nice.
No, just because I know the rest of the class isn't.
We'll have a final as well with this on it.
Really? What about the 10th graders?
What 10th graders are in this class?
What about H period?
There's no 10th graders.
Really? There was Henry. Henry.
I know, but then he moved to pre-cal honors. So.
But if there were a single 10th grader, we'd have to be on pause.
Huh?
If there was a single 10th grader, we'd have to be on pause.
No, not at all. They have to be up with the class. That's what's happening in my other classes. Yeah, so let's keep going.
That's not true. That's an AP, I thought.
So this is an interesting conversation we can talk about outside of class when I want to finish this problem. Okay. Lovely. Glad we're talking about 10th graders. All right, because we don't even have any. We don't have any. What the heck? Okay. So let's go through. What's the last thing I need to do? What's the last thing I need to do?
Get that last 0.
Yeah, make this 0.
Subtract. Oh. Multiply the bottom row by -1.
Exactly. So I'm going to replace. Cool. Okay. Replace R1 with let's see. Yeah, R1 plus -1 times R3, aka R1 minus R3. Oops.
How do you know if it's R1 minus R3 and not R2 minus?
Well, I'm trying to get rid of the 1 in the top left corner. So since I'm trying to get rid of it, I'm going to subtract R3 from it. Yeah. So what's my solution?
1 equals 1. Oh. Oh.
There we go. That is the solution. So the very right side gives you the solution. So beautiful. Beautiful.
We did it. We did it.
Awesome. All right, so special cases are when the matrix C cannot be written in row reduced echelon form. It either has no solution or infinitely many solutions.
So many solutions.
Fun. Okay, so we're gonna go through part B because it's shorter. Then I know we can at least finish it. So special cases, they either have no solution or infinitely many solutions. So we're going to use the method we just found out. We just did. So first step is to write an augmented matrix. So I have 2, 3, negative 1, 1, 1, negative 2, 5, 1, 2, 1, 8. All right. First step, make this 0. Yeah. So think about how you could make it 0. Huh? Exactly. No, I'm not going to do part A right now because I know part B I have enough time for. That's, yeah. Should take 5 minutes, but I only have 5 minutes. So I'm just subtracting row 2 from row 3. So 1 minus 1 is 0. 2 minus 1 is 1. 1 minus negative 2. 3. 8 minus 5. 3. So that's all I did. Okay. Cool. Now I have the bottom left-hand corner done. So think, what would be the next step?
The one above.
The one above it. I need this to be 0. Okay, so how can I make this one be 0?
Multiply that one by negative 2, right? And then subtract it by.
Okay. I could do that.
Or add it by the top one.
And just multiply the top one by negative 1/2.
Well, but then I'll have like 3, half of 3 over 2. Yeah.
I'm getting 3.
That's good. I'm just going to multiply the second row by 2 and then subtract row 1. So more or less, I'm multiplying the top one by negative 1 and then adding it, whatever. It's literally what subtraction is. Okay. Oops, that's green. All right. Okay. So I'm replacing the second row. So my first row, still the same. So I just copy that over. 2, 3, negative 1, 1. My second row. Okay.
That's a nice alert.
Yeah. It is nice. All right. 2 times are 2. So 2, 2, negative 4, 10. And subtracting the first row. So I'll subtract 2, subtract 3, subtracting a negative, same thing as adding, subtract 1. So I showed you the intermediate steps, that way you can see them. 0, negative 1, negative 3, 9. Oh, and then you just copy the bottom row over. Okay. So first was the bottom left-hand corner, then we went to the one above it. Now we'll go to the one next to it. Okay. So I'll make this one 0. How could I make this one 0? R3 plus R2. Believe it or not, this is the last step, so Good.
Yay.
And you'll see why.
Because we're not gonna be able to do anything else.
Trick.
It's gonna be no solution.
So literally, if you look at this bottom one, this means like 0 equals 12.
No solution.
What the heck?
There's
0 does not equal 12, so there's no solution. So the thing that we say is like, we put that nomenclature because that means empty set. So this is when you will have no solution. You have 0 equals 12. Imagine though, imagine everything went to 0 here, right? If I had, you know, blah, 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 blah as my like first 2 rows, but then I had 0, 0, like that. Oh yeah, 0 equals 0, and that would be infinitely many solutions. So that's what the top one is. Okay, so you should be able to do the majority of these. Literally, there's only one special case we didn't do, and I just told you like what happens. You go through the same process. Instead of getting 0 equals 12 or whatever number at the end, you get 0 equals 0. That's infinitely many solutions. 1, 2, 3, 4, 5. So 6 total problems. It's G period now. It's Thursday. Well, have a good weekend, and I'll see you Monday. We'll hit this hard. All right.
Is the next lesson hard?